second page of practice final 3. Solve the equation. That means we're going to find all the thetas that fit between 0 and 2 pi. So we have a sine and a cosine squared. We need to have everything in terms of one trig function. So I'm going to use my Pythagorean identity to get this cosine squared in terms of sine squared. So cosine squared is going to be 1 minus sine squared. So I replace my cosine squared with 1 minus sine squared of theta. So I have 1 minus sine of theta equals 2 times 1 minus sine squared of theta. Now everything's in terms of sine. I distribute 1 minus sine of theta equals 2 minus 2 sine squared of theta. Now I get everything on one side of the equations, on one side of the equal sign, and set it equal to 0 so I can factor. So I'm going to add my 2 sine squared of theta, 2 sine squared of theta. Okay, so I've taken care of this. I have minus sine of theta. Then I'm going to have 1, and I'm going to subtract the 2. So 1 minus 2 is minus 1. Now I can factor. I'm going to do bottoms up, so I'm going to multiply this back here, this 1 by 2. So I get sine squared of theta minus sine of theta minus 2. Now I can factor. My factors of 2 are 2 and 1. I need the 2 to be negative. So I have sine of theta minus 2 and sine of theta plus 1. But what can I not forget to do is to go back and divide by this 2 here. So 2, 2. I have my sine of theta equals 1, or my sine of theta equals negative 1/2. Where does my sine of theta equal 1? Well, on my unit circle, this point up here is 0, 1. This is my sine. Remember, the y value is my sine, so we have pi over 2 is one of them. I'm just going to write it up here. And negative 1/2. Where is my sine negative? It follows the y-axis. So here and here, I have negative 1, 2, negative 1, 2. This is 30 degrees or pi over 6. So I know it's going to be some version of pi over 6. So this is pi, or 6 pi over 6. So I add a pi over 6 and I get 7 pi over 6 here. Here is 11 pi over 6, because this is 2 pi or 12 pi over 6 minus a pi over 6, 11 pi over 6. So I have 3 answers for this one. Next one, they want a position vector. So the position vector is the final minus the initial. So I do Q minus P. So my vector is going to be 5 minus negative 9 I plus negative 9, minus negative 7 J. So this becomes 14, 5 plus 9, 14 I, negative 9 plus 7, so it's minus 2 J. Just watch your negative signs on that one. Okay, we have a negative 6 cosecant graph. I picked these based on cosine and sine. Cosecant is going to be graphed off of a sine graph. My sine starts at 0, 0 and usually goes up. However, we have a negative in the front. So my sine graph is going to start here and it's going to go down to negative 6, right? Down, and then my asymptotes occur where my sine crosses 0. So I really only graph a basic sine or cosine graph for this one, and you'll notice you'll be able to rule a lot of them out based on just this, knowing your sine and cosine. So my cosecant graph is the parabolas off the maxes and the mins of the sine graph. So what I'm looking for is I'm looking for my y-axis, and then I want a down parabola. So here I have my y-axis. I have a down one. This one's looking good. Here I also have my y-axis and then a down one. That's pretty good. This one I have my y-axis and then it's going up. This would be a positive cosecant graph. So I'm going to eliminate that one. This one gets eliminated because I go from this value here is 2 and -2. I know that this needs to be 6 because of my amplitude of my sine graph. Also, the period's off. It goes from -2 pi to 2 pi, meaning this is a period of 4 pi, and I have nothing changing my period, so this one goes away. So now I'm down to this one and this one. This one, it has a value of 2 here, so it's not 6, so it's gonna be wrong. But the other thing to notice is the period is actually right. So if you're looking at that, which you really don't need to know that, but the period is right. It's just the amplitude that's off. So look at this value, wrong. This one, it has the same period as this one, but look at this value here. This is a 6. That's how I pick it. Now, if I pick my right graph, I can more easily pick these. The range for your secant and your cosecant, it's going to be something like this. Y is less than -6 or greater than 6. That's your range. Your domain, you have to exclude all the asymptotes. So if you've graphed it right, notice this is at pi, 2 pi, 3 pi, -pi, -2 pi. It's all multiples of pi. So look for an equation that looks like multiples of pi. That's why it's this one, the k pi, where k is an integer. So right here. Last one on this section, use even odd properties. You don't have to know even odd properties, but cosine is an even function. So the cosine of -pi/3 will equal the cosine of pi/3. I tend to just draw this angle and figure it out. So where is -pi/3? It's down here. -pi/3 or -60. So if I have a -60, this is my 1 square root of 3, negative square root of 3, and 2. Well, what's the cosine? It's still going to be positive, so it's 1/2. That's it for the second part of practice test 3.